may be done to mitigate structural failure, particularly when it comes to the interior of the building or the exterior of the building. I'll just run through as fast as I can so I don't bore you too much. I know most people don't like listening to stories. People like seeing action. So, in definition, structural failure is seen as any loss in structural integrity or any component of the structure. So you build a house, beautiful house, and it decides to collapse. That is a structural failure. You build a house and you come into the house and you see that the walls are cracking. It's a structural failure because a component of the structure has been affected, right? So, what causes structural failure? What are the root causes of structural failure? You guys are the people on the field, right? But I'm giving you specification. For the engineering corridor, we have identified certain key factors as the reason why structures fail. And one of the reasons why structures fail is poor design. When the guys designing your structure are not engineers, quacks, and good, the structures will definitely fail. Secondly, when people don't adhere to specifications. There are specifications that you want to mold your block. There are recommendations from corridor. But when you don't obey those specifications, your structures will fail. Then there is the issue of corruption. Corruption is another reason why structures fail. You give somebody money to acquire certain type of product, and he goes back to buy whatever he wants. It's most likely going to lead to structural failure. Right? Now, I just mentioned 3. I don't want to bore you too much. I'll be very fast so that I can get to where I want to get to. Now, there are types of structural failures again that has been identified. And in engineering, we classify all these structural failures into 4 areas: compressive failure, tensing, buckling, or bending. These are all forms of structural failure. But I'm not interested in detailing you on how bending or buckling or tensing or compression, how it works. I want to go straight into types of structural failure. There are 2 stages of structural failure. I personally identify 2 stages: during construction and after construction. Sometimes you see buildings are being built and all of a sudden it's a building collapse. It's still under construction, but it failed. But that's not my interest again. I'm interested in structural failure after construction. Now the building has been completed, everything looking wow. And then one day you come into the house and you see that there are cracks in your room. What do you think is the root cause of such failure? Which is what we'll be discussing today. Now, for my engineering background, I've been an engineer for 18 years. The idea of constructing or building a project is for it to look good, right? Now imagine if after constructing a very beautiful house, and you come and you discover that the walls are cracked. What do you think is the cause of the crack? Maybe the guys who did the plastic did not do it very well, right? Or maybe the screening process was not adequate. So the desire of whoever is doing the building construction is for the building to look beautiful. And for you to make the building look beautiful, there's always a need for you to do what? To screen, which is where we are today. So everybody wants to screen. So what is screening? Screening is the use of cement, right? And sand to attain smoothness on the surface of the wall. So 2 ingredients are used in screening: cement and sand. You mix it with water, right? Sometimes in a proportion of 1 to 3 or 1 to 5, depending on who is screening, right? To produce a smooth surface. After which you are now obligated to paint. But in my few years as an engineer, there's something that has been prevalent. Most time when people paint or screen, I remember when I did my first project, wonderful guy, some Benin guy, came from Benin Republic, wonderful screener. He told me, "Okay, I don't want you to screen your house because after a while it will crack." And I kept asking, what is the solution to this cracking? Why does my house crack after a while? We went into so many engineering conventions. I remember in 2013 in Akure, Assembly of Engineers, and the topic was, why do buildings crack? Why does after speed will come out after maybe 3, 4, 5 years, you discover that the walls are cracking? So we in engineering family, we did a root cause analysis of the problem, and we discovered something that is very interesting. Why buildings crack? First, we discovered because of the unevenness of your cement and your sand. Because when you mix, we are not patient to get them to mix. And sometimes even the sand texture that we get are not even. So when you plaster or you skin, at some point, due to that unevenness, cracks begins to form. Then we went again to do another analysis. Why, apart from this unevenness, it cannot just be the cause of cracking. What is the root cause of cracking? We now discovered another very interesting thing. That the water molecule that you use in mixing your paint does not evaporate uniformly with the one that is left over as residue in your wall when you scrape. So due to that unbalanced movement of water molecule, whether you like it or not, anywhere there's water, there must be evaporation. Once it's hit, water will evaporate. So we are now able to identify why walls crack. And we kept wondering, now we know why it cracks. How do we stop walls from cracking? I mean, I think you're all familiar with walls cracking. I don't think anybody here does not know that. Either it cracks or it starts spinning. I've never seen, after a while, no matter how good you are, walls will crack, right? And the paints will peel. But luckily for us, we have people thinking ahead of us. And those are the guys that came up with the concept of the Navy wall putty. Very intelligent guys. I did a very beautiful analysis of the product. I sat down, I studied all the content of the product. What makes Navy wall putty exceptional? Because to me, you can't convince me as an engineer that you have a product that if you use on your wall, it will not crack. Then I tried studying, making analysis of the product. There are 3 things I found out. The content of Navy wall putty has 3 ingredients: white cement, polymer, and minerals. White cement, polymers, and minerals combined in a proportion that is adequate to withstand heat, water, and stress. How did they achieve this? What is the function of white cement? By combination, white cement is made up of certain ingredients by itself. White cement is made from limestone, clay, specific oil. There are specific oil they use to make white cement, and a little bit of gypsum in a proportion that makes it white cement. What is polymer? Polymer is a product that is used to create thermal resistance and give strength to any product. The same thing with minerals. There are certain minerals that contain a living organ, like the silica fluid. It helps to create thermal resistance. I mean, one of the major reasons why war cracks is because of heat. Once it is heated, and sometimes people ask you, where does the heat come from? Human beings themselves generate heat. And once the wall is heated, there tends to be an even expansion and contraction. And it will crack, which is what this product takes care of. The that unevenness, that's strength, that's tensile ability to withhold heat because of the kind of ingredients that makes up the product. Like I said, I'm not here to bore you. I want to round up, I want to say something. Has anybody wondered why clay fly? Has anybody wondered why clay fly? If you can understand why clay flies, you can now understand how this product works. In as much as there are environmental factors that tend to affect our product, like thermal heat, water, air, and all other environmental factors that tend to affect anything we are doing, the same environmental factors play a huge role in the movement of an aircraft. But for an aircraft to fly, those environmental factors will have to be kept in check. And how do we keep them in check? Every factor that tends to contribute dangerously to the effectiveness of a product has to be kept in balance. And that is what maybe Putty does. Just like an aircraft. There are four forces acting on an aircraft. There's a thrust, there's a drag, there's a lift, and there's a weight. For an aircraft to fly, these four forces must be the same. Just like your living Putty. There are so many factors that contribute towards cracking and structural damages. But for your wall to remain intact, those forces that tend to pull it down must be put in check. And that's what moving Putty does. With moving wall Putty, your wall is guaranteed to stand the test of time. Thank you.